All right, so today we're going to continue doing examples of transformations of functions. So basically we finished with all types of transformations. Horizontal shift, vertical shift, what else? Reflection about x-axis, reflection about y-axis, vertical stretch and compression, horizontal stretch and compression. Remember that? So there are 8 of those. Now what we're going to do is do the examples. So let's do the first one then. Let me share the page, share desktop, and OneNote. Where is my OneNote? Okay. And I have to open Mac 60. And which one is it? 2.4? Oh, where is 2.4? So it was 2.3? Right, I know. But, oh no. 2.2. Okay, let me find it. Give me a second. Is it in a different file? No. You know what? Let me just open a new page. Okay, I don't know what it is. Did I delete it? I hope not. Okay. It doesn't matter. Let's just make a new page. So this is a continuation of 2.4. All right. Or maybe I could do this. Yeah, I don't have it here. I don't know. Okay. So what we want to do is the following. Yeah. For example, for each of these functions, write the basic function. B, state the transformation. C, choose 3 points from the basic function. And show each step of transformation. And then the last one is graph the transform function. All right, so that's what we want to do. So this is the function. Number 1 is f of x is equal to 2 times x minus 3 squared minus 4. All right. Are we ready? So for each function, do this transformation. Yes, continue. So A, what is the basic function which is related to this function? So it is y is equal to x squared. That's right. B, what are the transformations? So let's label it. Yeah. 1, This is the one, 2. So how is this different from y equals x squared? So the first one, this number 2 is different. What else? This negative 3. What else? Minus 4. So there are 3 transformations that I'm applying to y equals x squared. So that my function is what is given here. So what was the first one? 2. Yes. What does this 2 do? What type of stretch? Vertical, horizontal? Yes, this is a vertical stretch by a factor of 2. All right. Good. Now, what about the second transformation? X minus 3. What does this minus 3 do? Yes, so shift right 3 units. Okay. And what does this negative 4 do? Shift down how many units? 4 units. All right. Are we okay so far? Yeah. Okay. Now, the next one is I need to choose 3 points from the basic function. So my basic function is y equals x squared. What 3 points you think represent y equals x squared? Well, of course, the shape is a parabola. Then, of course, we have to include the vertex, right? So what is it? 0, 0. What else? 1, 1, and negative 1, comma 1. Yes. So that is, these 3 points represent y equals x squared. All right. Now, let's apply each of the transformations. So vertical stretch by a factor of 2. Does it affect x or y? If you have a vertical stretch, does it affect x or y? Y. So actually, we multiply y by 2. So I'm going to copy the x. So the x is the same at this point. So negative 1, 0, 1. That's your x. And then I will multiply the y by 2. So 1 times 2 is 2, 0. And then this is also 2. So far, so good? Okay. Now, shift right 3 units. So when you're shifting right, what do you actually do? Add 3 to, yes, or add x by 3, or add 3 to x. Yeah. How about the y? Well, at this point, it stays the same. So I will copy the y, 2, 0, 2. And what will we do to x? We add 3. So negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. Okay, so next one is, sorry, let me just do it here so I have space to write down. Last one, last transformation. So this is your first one. This is your second one. The last one, what would that be? Subtract y by 4. All right. So the x stays the same, 2, 3, 4. And then we subtract y by 4. So 2 minus 4, negative 2, negative 4, negative 2. There you go, you're done. Yeah, let me move this a little bit so I have space to graph. All right. Okay, so this is this one. I moved it a little bit, so I have space to graph. All right. Question so far? Yes. Yes. The transformations are from left to right. You're right. Yeah. The order also looks like that. So, for example, we vertically stretch it first. Look at this. We vertically stretch it first before we shift it down. Yeah. So you can't say, oh, I'm shifting down first and then vertically stretched it. So no, yeah, it's left to right. Yeah, and if you shift it down first and then vertically stretch it, the answer would be different also. Yeah. So we want to keep it in this order, left to right. Good question. So left to right. All right. Good question. So now let's graph it. Let's graph the function. All right. So let's see. 1, 2, 3, 4. 1, 2, 3, 4. Should we grab the original? Well, actually, you don't have to, yeah, because we only need to grab the transform function. So this is 2, 4, -2, -4, -2, -4, 2, 4. Okay. So 2, comma -2 is right here. All right. 3, comma -4 is right here. And 4, comma -2 is right here. All right. So it looks like this. This is my transform function. Okay. This is my new function. Now, if we want to grab the original, so it's -1, comma 1, 0, 0, 1, 1. So the blue one is the original. So the blue one is y equals x squared. That's my original. And this one is y is equal to 2 times x minus 3 squared minus 4. Do you see it's vertically stretched? Right? So the shape is not exactly the same. Yeah. Well, it's vertically stretched. So that's why this is a little taller, right, the transform one. But you could see the vertex. What do I do to this point? So I shifted right 2. Oh, so 1, 3, and then I shifted down how many? 4. Yes. So this is, you could see the transformation also. This is 4, comma -2, 2, comma -2. All right. Yes, no, maybe so. Do you see that the graph is vertically stretched? Yeah. It's taller? Yeah. Okay. And this is shifted down 3. So 1, 2, 3. I'm sorry, shifted right 3 and then down 4. Yeah. Interesting? Do another one? Let's do another one. Yeah. Okay. Let's see. What function should we use? What about square root? Yeah, let's use square root. Okay. Do another one. Use square root. So, number 2. Square roots. So this is my function. F of x is equal to 2 times square root of negative x plus 3 plus 1. Now, let's think about this. What am I supposed to do? So, what is my basic function? Square root of x, yes. So A, basic function, y equals square root of x. But what is different here? Do I have square root of x? No, I have square root of negative x. Yeah? Then I need to do something here before I could actually do the transformation. So I need to rewrite these into f of x is equal to 2 times square root of, take out the negative. What am I left with if I take out the negative? X minus 3 plus 1. So it's really important that we take out the negative here so that we know what type of transformations. Yeah. So tell me how many transformations do I have here? Actually, this is 4. Yeah. So this is the first one. And then the negative, this is the second one. And then this one. All right. And then, yes. So that's why I need to factor out the negative. So suppose I rewrite my function as, this is exactly the same thing. 3 minus x plus 1. Then you have to factor out the negative as well. Does that make sense? So look at these. I have a negative x, and you have to change it to this form and then to this form. Yeah, before we could start doing whatever we need to do. All right? Because 3 minus x and negative x plus 3 is the same. Yeah? So anyway, if we have a negative, we have to factor it out. That's the bottom line. Okay? Okay, good. Now, so this is my basic function. So what about the transformation? And we labeled them, and there are 4. Okay, so what does this 2 do? This 2? Yes. Vertical stretch by, yes, so vertical stretch by a factor of 2. That's right. What about this negative? Reflection? That's right. Negative always reflects. So there are 2 things about the x-axis or the y-axis. Does it affect the x or the y? X. So if it affects the x, it is reflection about the y-axis. Okay, do I only have 2 students in this class? Okay, so how about the others? You guys have to answer the questions too, right? Yeah. Now, third one, this 3. So, who wants to answer? Josh? What does this, the third transformation? Oh, shift. Shift where? To the right or to the left? That's right. So we just say shift right 3 units. All right. And then +1. Sophie? Yes, shift up 1 unit. You were correct. Good. So we do have four of them, right? Okay. So now we will choose basic 3 points from the basic graph, y equals square root of x. So what points do we choose? 0, 0, yes, that's right. What else? 4, 2? Yes, but there is smaller one, right? 1, 1? Okay, and 4, 2. All right, good. Okay. So now, let's see. So vertical stretch by a factor of 2. So Jennifer, can you tell me, what do you actually do to your x and y if you vertically stretch it? Any idea? Multiply which one? You're correct. Multiply y by 2? Okay, cool. You vertically stretch it, so it doesn't affect the x value. The x doesn't change. It is just the y. All right, so copy the x. 0, 1, 4. And then the y, we multiply by 2, so 0, 2, 4. Right? Okay, so now shift right, no, I'm sorry, reflection about the y-axis. So Yanli, do you want to try to tell me what they are? Does it affect the x or the y? You subtract it, or what do you do to it? Or what do? You subtract by 1, or you multiply, or what? Multiply x by? Yes, multiply x by -1. Or you could say replace x by -x. So either one would do. You're right. Thank you. So the y stays the same. Yeah. So let me see. So 0, 2, 4. And then the x, we multiply by -1. All right. Yes, Andrew, right? Okay, what is it? Yes, so if I have a negative square root of x minus 3 plus 1, this is a reflection. It's affecting the y before. If it is up there, now it's down here. So it's reflection about the x-axis, and it's affecting the y. Yeah. Good question. Yeah. All right. Now, there are 2 more. So let's see if I have space to graph later on. The next one, shift right 3 units. So let's see. Shiyun, can you tell me what you do to x or y? So if we shift right, what do we actually do? 2? Yes. So add x by 3. Perfect. So 0, 2, 4. So we add 3. 3, 2. Yes. There you go. Okay, so Alex, shift up 1 unit. What is it that you're doing?
Y plus 1.
Yes. Add y by 1. So the x stays the same. 3, 2, -1.
And 1, 2, 5.
Yes, that's right. Is
Can
it?
you not do those last two steps in the same step?
Well, I'd like you to do it step by step. You mean you are going to write these and then just add by one?
Yeah, add x to 3 and then add y to 1.
Oh, and then write it on.
The same thing.
I'd like you to do it by step. Yeah, because I want to see the. Actually, you can. The answer's the same, but I'd like you to show each step. That's what it means. Show each step of transformation. Yeah. Yes. Practically, if you do that, it's not wrong. The answers would be the same. So let's see. Let's graph it now. All right. Maybe I should graph it here. Okay. All right. Let me see. Negative 1,5. So 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Okay, so 3, 1 is right here. 2, 3. So 0, 0 is 3, 1, 2. Oh, let me label this first. 2, 4, 2, 4. Negative 2, negative 4. Negative 2, negative 4. Okay. So 2, 3. 3, 1. 2, 3. It's right here. And then negative 1, 5 is right here. All right. Okay. So this is 3, 1, 2, 3, negative 1, oh, actually it's right here, right? 5, not 4. So how does my function look? Does it continue on this side? Do I go down? No. Yeah. Why not? Well, this is my original function, 0, 0, 1, 1, 4, 2. This is my original function, y equals square root of x. This is my transform function, y equals to 2 times square root of negative x plus 3 plus. Okay. So this one doesn't continue. It starts here. So same thing here. This is the transformed value of 0, 0. Yes, Lulu? Do you have an example? Do you think you can do it? So just say on the exam, I will ask you to do a problem on transformations. Then I will ask you A, state the basic function. B, state the transformation. C, choose the point from the original function or the basic function and show each step. And last one, graph the function. So this is it. You need one more example or you're good? One more? Okay. Let's see. What do we want to do? What function should we use? One more. What function should we use? Maybe if there is absolute value, then there's no difference. Negative and positive. X cubed is well, we could try X cubed. Okay. So, what about these? Okay. Well, actually, for X cubed, you can't use. Let's just use the square root again. Okay. So, f of x is equal to -2 square root of, probably you should try this first, right? -4 minus x plus 3. So I'm going to wait a little bit. So what is A? Question A. Okay, state the basic function. So you can start with that. By the way, you should rewrite these first, right? Once you have a negative x here, what do you have to do? Factor it out. Yes. Okay, and put x first, these ones here. Did you guys copy? I'm going to try to find the other notes, okay? Hold on. Let me close the recording and then I will record again. Okay, so let's continue. Let's share the desktop. All right. Oh, it doesn't have the yellow. We start applications here and use the new dimension. Let's share. Let's see if I can do it. Yeah. Okay, so, all right, so let's start. So let's label this first. Oh, or actually here I see minus x. I need to rewrite these first. So f of x, how do I rewrite these? -2 square root of negative of x plus 4 plus 3. Yes. Good. Now, the first one is this negative. The second one is this 2. And what else? The negative, and then the 4, and then 3. So there are actually 5 here. Yeah. Which is a lot. So A, basic function. So what is the basic function? Y is equal to square root of x. By the way, this transformation is valid for anything. So later on you learn log. So you can have y is equal to -3 log base 10 of x plus 2 minus 3. So what does this mean? What does this mean? What does this plus 2 mean? What does this plus minus 3 mean? So it's not only for these, but we haven't learned log yet in this class. That's why we don't do it. But these transformation rules or whatever we do, guidelines, work for all functions. Yeah. So this minus is reflection about the x-axis. This is vertical stretch. This is shift left. This is shift down. Same thing. Okay. All right, so basic function is y equals to square root of x. Good. So what are the transformations? So remember, negative doesn't change, doesn't make a compression. What does negative do when we're doing transformation? Reflection, yes. So reflection about, which one is this one? X-axis. So the first one is about x-axis. You're right. What makes a vertical compression? So instead of 2, I'm going to put half. That's a vertical compression. Does that make sense? So not 2, but half. Or something that is less than between 0 and 1. That is going to give me a vertical compression. Yeah. Now this 2, what is 2? Vertical stretch. But if I have put half, then that will be vertical compression by a factor of 2. Maybe I should put half, right? So, you know, yes. Now, the third one, this one, negative, what does it do? Reflection. So negative is always reflection about which axis? Y-axis. Good. Number 4. What does this plus 4? Shift where? Left. 4 units. And then plus 3. Shift up 3 units. All right? Okay, good. So now choose 3 points from the basic graph. So from y equals square root of x. What are the 3 points? 0, 0, 1, 1, 4, 2. So square root of 4 is 2. Square root of 0 is 0. So basically, I got these from my basic graph. So what is square root of 0? 0. Square root of 1. Square root of 4 is 2. So this is how I got these numbers. Right? Okay, let me erase this. Now, the reflection about x-axis, what do you do? So it affects the y or the x? The y. So what do you do? Yes. Replace y by negative y. Or what is an alternate way of saying it? Multiply y by same thing. Yeah. So 0, 1, 4, 0, negative 1, negative 2. Yes? Or you could say multiply y by negative 1. Exactly the same. Now, the 2. Vertical stretch. What do you do? Multiply y by 2. Actually, you could do 1 and 2 together. Why? Because you're multiplying y by negative 2. Yes? So actually, 1 and 2, you're doing the same thing to y, which is multiplying by 2. By negative 2, I'm sorry. So you could actually do these two together. Multiply y by negative 2. So here, 0, 1, 4, copy the x, and then this will be 0, 2, 4. Okay. So far, so good?
Wouldn't it still be negative 2?
Yes, it will still be negative 2 and negative 4. Thank you. No, I completely forgot. I was multiplying it by negative 2. Okay, so next. What do we do next? Reflection about y-axis. What is that? Multiply x by negative 1. What is an alternate way of saying it? Replace x by negative x. Exactly the same thing. Okay, so maybe replace y by negative y. This is the same as multiply y by negative 1. Here, this is the same as replace x by negative x, whatever you want. Okay. So, 0, negative 1, negative 4, 0, negative 2, negative 4. All right. Next, the fourth one. Shift left 4 units. What is shift left 4 units? Yes, subtract x by 4. So the y is the same. 0, negative 2, negative 4, and then subtract these by 4. So what do you have? Negative 4, negative 5. Oh, okay, good. Last one. Shift up 3 units. Yes, add y by 3. Okay. So when you add y by 3, what happens here? Yes, so 3, 1, negative 1, is it? Negative 4, negative 5, negative 8. All right. Yeah. Now, this is true also know when you take trigonometry later on, you have to you have to do it for the trig functions. Is anybody taking trig? Are you guys doing it yet? Did you shift? Did you change the amplitude, the period, etc.? The phase shift?
Yeah.
Oh, you already finished. So you understood what we're doing here, right? This is exactly what you're doing. Phase shift, amplitude, and you change the period. Probably not so much as reflection, right? Not so much, right? Yeah, trigonometry doesn't involve much reflection. Okay, so -8 comma, so 1, 2, 3, 4, 5, 6, 7, 8. Because in trigs, the functions, well, cosine is even and sine is odd. So if it is even, then cosine x is the same as cosine -x. If it is odd, then sine x is negative sine x. So that's why it doesn't involve much reflection. Yeah. All right, -4, comma 3 is, okay, let me label this first. 2, 4, 6, -2, -4, -6, 2, 4, -2, -4. All right. Where is this? So -8. Oh, I didn't have -8. Here, -8, comma -1. Sorry, I have to do it here. Oh, I labeled that wrong? 2, 2, oh, 4. Yeah, I think I did label it wrong. So this is -4, -6. Oh, yeah, you're right. Yes, you are completely right. -8, comma -1. And then -5, comma 1. And then -4, comma 3. All right. Okay, so this is your function. Why does it look weird? It doesn't look like a square root function at all, right? Because you reflected. Well, first of all, you reflected towards the y-axis, about the y-axis, and reflected about the x. That's why it looks like this. Yeah. Okay. Good. Are we okay so far? Yes? Okay. So, should I give you a quiz now? So let's have a quiz now. 7 minutes, one problem. So Math 260 quiz 2. Quiz 2. You can look at your notes, okay? Today's name and today's date. What is today's date? Yes, 9/21/2016. Okay, so this is the function. Basically, I'm asking you the same thing. I'm going to make it easy for you. So f of x is equal to -half times absolute value of x plus 2 plus 3. That's it. So A, what is the basic function? B, state the transformations. C, choose 3 points. So this is what we did. So this is the deal. You can look at your book or your notes, but you cannot talk to anybody or look at somebody else's work. Yeah? So you have 6 minutes. So this is the basic function is absolute value, right? Okay. So I'm going to write down what A, B, and C was. So A, take the basic function. So you remember. B, take the transformations. C, choose 3 points from basic graph or the basic function. Show each step. And then we graph the transform function. Are you done? Okay, you can leave now. Bring it tomorrow. Yes? So will you remember?
Yes.
Okay. So bring it tomorrow. Yeah? Okay, guys. See you tomorrow. So bring it tomorrow. Don't forget. And please stay awake in my class. I know it's early, but I like to give quiz in the morning. Yeah. Okay, I'll see you tomorrow. Did I scare you? Well, sometimes you guys have to wake up, right? So next time, I'm going to collect it. If I give in-class quiz, next time I'm going to collect it. Yeah, so you have to be awake in class. Oh, yeah, you can. Does everybody have their portfolio? Yeah. Okay, I can't really talk about this because this is my quiz, but I could answer the other question. So if you have another question, oh yeah, just put it there. So if we have, remember last time I gave you the basic graph? The basic graph, the library of functions. We have, do you have the notes from last time? The basic graph, I talked about all the other functions. 2.3. So this one. Let me. Oh, actually, it was 2.4. The greatest integer function, those things. I think it was 2.4. Yeah. No. Before this. So, well, you have to look at it here. Well, anyway, if you have y equals x squared, so how does y equals x squared look like? Why don't you do it? No, you can choose the staple. If that's not the coverage, you should just staple it. Yeah, just like that is good. Yes.
2.1.
Yes. Oh, 2.1? Actually, okay, that's fine.
Or should I have one?
No. Can I borrow this? So remember y equals x squared is like this, right? Right? I'm trying to remember. Okay, so this is 1, this is 0, 0, this is 1, 1. Or actually, you could get it by, so you have to know y equals x squared is a parabola. Okay? So if, so the vertex is 0, y is x squared. So if x is -1, what is -1 squared? Yeah, so this is 1. 0 squared is 0, and then 1 squared is 1. Oh, 1 squared is 1.
And we could just pick any place.
Well, as long as it's representative, for example, it has to include the vertex, and it has to include the left and the right.
Okay.
Does that make sense?
Yeah, I need to review the,
Right.
yeah.
Yeah. So if you choose, for example, because the other points, there's another one here, which is 2,4. So if you're choosing 0, 0, 1, 1, and 2,4, that's not representative of a parabola if you only have one side, right? Does that make sense? So representative means, well, it has to convey the general shape.
Okay.
Yeah? Yes. Oh, yeah, okay. No, I don't.
I'll use that list.
Oh, he has it, yeah. Okay. Thank you. Yeah. Yeah, of course. Yeah, you need it to be private. You want me to go on?
Well, let's see. Yesterday I had another episode and I had to go back to the doctor. And well, basically I'm getting worse. I'm not getting better. So maybe a little bit late on my homework. But because I want to draw my classes, but I can't do it because don't feel good, but I'm gonna try to keep up with all the work.
Oh, okay. Okay. Okay, so you'll try your best.
Yeah.
Okay.
Okay.
All right.
Thank you.
Thank you.